right, this is my geometry. This is density. Okay, so now for what we have here, density is the amount of matter that an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. Mass is referring to its weight. Okay? Volume is its three-dimensional size. Three-dimensional size, yes.
Okay, so I have a question. Whenever we're dealing with density problems, do they always give you the mass, or are we going to have to solve?
You're going to have to solve for some of those. So that's why it's set up like this, because you're going to have to write out each one depending on what you're doing. So I'm going to help you guys out. And so what that means is you're going to actually have to do your notes and actually look to see what we're working with here. So if I was looking for just the mass, this is density equals, right? What would I do to get mass by itself? Multiply by volume, right? So we could actually say that mass is equal to density times volume, right? Okay, what else can I know from that? So if mass is equal to density times volume, what would I do to try and get volume by itself? Okay, look right here. Look right here. Look at this one right here, okay? What would I do to get volume by itself? Divide by?
Density.
Density, because I want volume by itself, right? So I'm going to divide both sides by density. So I could say that volume is equal to mass divided by density. All right, so we're going to do the math for this, for each one of these. So I'm going to show you guys. So I'm going to make my calculator now. I want you guys all, when you pick up the calculator, clear the calculator, please. Because especially since a lot of the stuff is, the class before this is actually calculus 2. So they're doing all kinds of crazy stuff. So you just take the calculator, and how do I clear it? On your scratch pad, hit dock and the letter B. There you go. Clear the scratch pad, and it reverts back to regular settings. Okay. Determine the volume of each log. Okay, so I'm looking for volume. Okay, so to find the volume, I first have to figure that out. Now, I need to find a volume of a log. So, you guys on the back of this or underside page, or for those people that don't have the notebooks, you guys are going to do it on the back side here, okay? So we need to actually do the math for this to find the volume. If you notice, is volume given? No, volume is not given. So I'm going to write, so these are logs. What's the normal shape of a log?
A cylinder.
Okay, so I'm going to do that. So I'm going to do 2 cylinders. All right. So I have those two. So I'm going to call one fir and the other one a redwood. This one's going to be fir. Okay, F-I-R. F-I-R, yes. And this other one's going to be a redwood. So I have fir and redwood. It says diameter of the fir is 6. Radius is what?
3.
Very good. I need that information to find the volume. The diameter of the redwood is 8. So my radius is 4. The height of the fir is 17, and redwood is 12. So right here I'm going to put 17 and 12. Okay? So if this shape is a cylinder, how do I find the volume?
Pi times radius squared times height.
There you go. Volume is equal to pi r squared h. So that's going to put right there. Now let's go ahead and do that. So that's going to be, volume here is going to be pi times 3 squared times 17. Now in your calculator, you guys are doing it with the pi in there also.
480.7.
I heard you. I'm just putting it in myself. So volume is going to be about 480.7. What are my units?
Centimeters cubed.
Very good, centimeters cubed. Now we're going to do the same thing on this one. So this is going to be, volume is pi 4 squared times 12. Volume is about 603.2. What are my units?
Centimeters cubed.
Very good. Centimeters cubed. There we go. So I have my volumes now, right? Okay. So that's important. So I'm going to go back to the other page and I can actually do my math from there. So determine the volume of each log. So volume, okay, is equal to mass divided by density. Okay. Did we already find the volume of each log?
Yes.
Okay, but we're going to use this also later on. Close the door, please. So, each log, so I'm going to say my fir, so FIR is
480.7 centimeters cubed.
okay, and now my redwood,
603.2.
603.2. Are we okay now?
Yeah.
Okay, so we got the volume, that's important. Now find the density. Ooh. Density is supposed to be, density is mass divided by volume. So what is the mass? So that what that means is the weight of the item. So I'm going to put right here next to this, I'm going to put weight. So that's the weight, and these are in kilograms right here. So the weight is going to be here. So now let's flip it over. So it should be mass divided by volume. So my fir should be my mass. What was it again? Divided by the volume, which is
480.7.
yep. Okay, let's do that math. So I'm gonna round off a couple of this one, just so you guys can see, because when we're talking about this being more and more decimal places, they're actually important. So you'll see why here in a minute. 0.5284. and this is mass divided by the volume. So the density is a ratio of mass divided by volume. So my units on this is going to be mass, which is, what was kg, kilograms, and centimeters cubed. So it's mass divided by volume. Pacho. Paola's leaving. All right. Bye. All right. Okay, so what this actually means is this is how much it weighs for every cubic centimeter. So it weighs this much for every cubic centimeter. All right, now let's do the same thing for the redwood. So that's going to be my density is equal to, what was the number for that one?
603.2.
271, thank you.
Well, 271.
All right, so now let's do the math on this one.
0.4493.
So density, 0. What?
4493. I rounded it.
Okay, very good. And what are my units in this one?
Kilograms.
Yep, very good. So it's kilograms, cm cubed. So this is going to be a ratio. So now, for every centimeter cube, every cubic centimeter, it is this many kilograms. Every cubic centimeter, it's this many kilograms. So now help me as I carry it back over to this. So my fur was 0.
5284 kilograms per okay,
And redwood,
0.4493. I have a question.
yes.
Do we have to put the 0 point? Just be point.
Yeah, you can, but I usually don't put. Fine. We're dealing with small numbers, so I want to make sure that's accentuated. Now, which one is more dense?
Fur.
The fur, right?
Yes.
Because that one weighs more for every cubic centimeter, right? So this is kind of like Cartman from South Park. What's Cartman always say?
Oh no, Cartman.
Cartman.
I thought you were talking about.
What does Cartman always say? He said, "I'm not fat. I'm big bone." Okay, so it's referring to the density versus the actual size. So if we're looking at this, which one was bigger? The redwood's bigger, right?
Yep.
The redwood is bigger, but the Douglas fir is actually denser. So every cubic unit, so if I take 1 cube of this and 1 cube of that, so the Douglas fir is going to weigh more for every one that is the same volume. Okay? So we're going to write that out.
Well, it's probably the weight.
Okay, so now, this next one, when we're talking about precious stones, those ones are very, very dense. Very, very dense. Like diamonds are supposed to be like the hardest thing in the world, but you know, they make things harder than that, but that's synthetic and all that. Anyway, all right, calculate the mass of a ruby which has a density of this and a volume of this. Okay, so what am I looking for?
The mass, or the weight.
I'm looking for the mass, right?
Yep.
So if I go up to the top and I say, hey, mass is supposed to be equal to what?
Density times volume.
Density times volume. So I'm going to write that out. So mass is equal to density times volume. So I'm going to put d times v. So mass is equal to my density, which is 0.19 grams per cm cubed times 1/6 cm cubed, right?
But it's actually 1.6.
Oh, I'm sorry, you're right, 1.6. Kind of messed up that one. I don't know. Yes? Yeah, he came back. Go ahead. Now, I want to show you guys this. This is grams over centimeters cubed, right? Grams over centimeters cubed. And this one is centimeters cubed. So if I were going to cancel these out, because that's why I wrote this out like this, the centimeters cubed are going to go away. So my mass of this item is going to be in grams now, isn't it? So let's do the math. So it's going to be 4. So that's going to give me my mass is equal to 6.7, and that's going to be,
Grams? Just grams?
yeah, 6.7 grams. Now, mass refers to the weight of an item. So if I'm comparing this to the Douglas fir or one of those other items, this is going to be a lot heavier, right?
Yeah.
If they are the same size, this thing is going to be a lot heavier. That's what it's referring to. Because it has a lot heavier density. Hey, can you please put it up there? I don't want to have to yell at you during this. All right, you guys, let's take a look at the next one. Population density. Population density is probably one of the ones that you'll probably end up doing the most of. So population density, so my formula is going to be PD. So there's my population density, is whatever the number
Is it times like?
divided by
Oh.
area. So I wrote it number because we're not always talking about people. We could also talk about, you know, lions and tigers and bears in a certain area. So over whatever area that we have. Okay? So now, if population density is equal to the number divided by the area, okay, what would I do to figure out the number? To get the number by itself, what would I have? That would be the population.
Times the area.
Okay, so it would be right here, the number. So that's going to be my population. Okay, my population. So that's my number of people, my population, how many in the that I'm dealing with. So my population, so it's going to be area, so my population is equal to my area times my population density. Okay, so now if I have it like this, area, so what would I do to figure out the area? Divide by population density. So I can say area is equal to population divided by population density. All right, let's see. Now, I'm going to go to the back of this so you guys can see this. Okay, so if you're one of those people that are working on the back, you flip to the back. If you're not, you're working on the page underneath. So it says, Colorado has a population of this. Its territory can be modeled by rectangular approximately 280 by 380 miles. Find the approximate population density. So it could be modeled by a rectangle, which is what?
280 by 380.
Yes. So okay, and these are miles, right? And this is Colorado. I probably misspelled Colorado, but not like I have anyone from Colorado watching. It doesn't matter. Okay, so now, you notice I didn't even capitalize it, so that's how I feel about it. All right, so how do I find the area? Okay, so that's going to give me what? Multiply these two, length times width, base times height.
That's like 280.
106,100.
What are my units?
Miles. Miles, right? Yeah.
Nope.
Miles.
Nope.
People.
Is this area?
Oh,
Yeah.
Square. They're in miles, right?
Yeah.
They're miles, so if it's an area, it's going to be mile square. Square miles. Are we okay?
Yeah.
So my population, my P, is equal to what? Give me the number off that.
5,268,367.
367?
Yup.
Okay. And these are people.
Yup.
So, I'm looking for the population density, right?
Yup.
Pacho. Okay. Bye. Registration. You. So, let's do the math. So my population density, PD, is equal to my population, which is 5, 2, 6, 8, 3, 6, 7, divided by 106,400. Yep.
49.5.
So this is going to give me about 49.5. What are my units?
PD.
What was it? What was the top number? It's people, right?
Yeah.
So it's going to be people
Oh. Square.
Over miles.
over
Miles squared.
mile square. So what does that mean?
Like for every square mile, there's 49.5 people.
Very good. That's exactly what it means. So it means that there is, every square mile, there's 49.5 people.
Is that a real thing?
At the time it was, but once you get into, we have a project coming up later on where we're actually going to be dealing with some other like states and stuff like that. Just so you know, a person's a person no matter how small. Okay. All right, so let's take a look. So this is fine. We're going to do some more work with this later on. I have another thing for it. But with the different populations, and we'll talk about states. And every year I do it, I always update it with the current records. All right, so here we go. This is page 38. Here's some more wood. Here is metal alloys.
Is there a backflip?
Okay, look, everything that we've done already is already here. All right, don't forget, like, share, and subscribe.